Hi, and thank you all again for joining. This is Chris Woodfield with the Program Committee. One reminder is that we're going to have Birds of Feather session immediately after this talk. The links to the Zoom links to those sessions, I believe, are in the agenda. If they're elsewhere, I will make sure to put that into the chat. I'm going to be introducing Job Snijders, who's going to be discussing lesson learned in the use of RPKI to improve internet routing. Job is a IP development engineer with NTT, a large international IP network, and worked on NTT's RPKI implementation. So with that, thank you, Job, and you have the mic.
Thank you, Chris. I'm Job Snijders. I'm based in the Netherlands, working for NTT, standing in my garden, wearing my RPKI wooden clogs, because safety first. And today I want to talk a little bit about what NTT went through to get to the point where we could deploy RPKI, what the key points were that I want to share with others as you start to go through this process, what to look out for, how to help your coworkers, and what the other people in the industry are doing. And then at the end, there is Q&A, of course. So what is this internet thing? Here we have a nice abstract image where a 3D graph was generated by looking at all IP4 and IP6 adjacencies that can be observed from NTT's perspective. And beautiful image, but this is not the real thing. This is the real thing. My friend Mark, based in South Africa, helped build an ISP for the sole purpose so he could stream music and video from his from his garden. And this is the internet I would like us to protect, that we have a secure communication channel from a routing perspective, that packets arrive at the right place. The BGP protocol is what we use to wire all this together. There are many paths. Maybe you use NTT as an upstream, maybe others, maybe you have direct peering. All of this is glued together with BGP. And this BGP thing, we call it the default free zone, is sort of a natural resource. It's like the Rhine River that starts in Switzerland, goes through Germany, Belgium, and then finally the Netherlands. And it's very curious how we have to govern such a natural resource that's kind of sprung out of the ground and is distributed through a bunch of countries. Because if one of those countries would start polluting the river to get rid of, say, toxic waste or something else, everybody downstream suffers. And I see in this a strong analogy to how we could view the default free zone as a shared resource for which we have to care together. And if something happens in one part of it, it can negatively affect many other parts. So a simple problem scenario. Imagine you have a network and you connect to a bunch of peers to reach the rest of the network. And then at the end of the AS paths, you see multiple paths to a single prefix, but you see it through network A as an origin and network B as an origin. Which of these is the actual proper destination to reach that specific set of IP addresses? From BGP itself, we cannot conclude anything. So we have to look to other sources. But this scenario, this is the simplest scenario that we have, and this represents the problems we have with BGP optimizers, with typos, with router defects, with you name it. This is the core problem. So what have we done so far to protect ourselves? In NTT, we use routing policies. We carefully tag each and every route we receive with BGP communities to later on the egress side ensure that we are propagating the right routes to the right peers. We use maximum prefix limits to mitigate the negative fallout from full table leaks. There's AS path filtering on every eBGP session in the shape of peer log. We've had IRR around for many years, decades. We use this to create what we call allow lists. If the prefix is not on the allow list, we will not accept it. And now on top of all of this, we also have RPKI-based BGP origin validation. What is RPKI? In a nutshell, it is a very official-looking document. Official route origin authorization for immediate distribution. Henceforth, only Job Snyder's is authorized to originate IP prefix blah, blah, blah. Signed NTT as certified by Aaron. And this document, this we call it RPKI ROAS, this is the foundation of how we can do origin validation. And this document is cryptographically verifiable, it's machine readable, and it has slightly different semantics than, for instance, IRR or letters of agency. It is a far more trustworthy source of information. And we can apply this information in near real time in our routing decisions. So how do you start with RPKI? It's easy. You go to the NIR or RER that manages your IP space. You ask them, how can I create ROAS? They'll point you to a website or a portal or a different mechanism, and off you go. Creating ROAS, it's tedious administrative work, but all in all, it's fairly easy once you get the hang of it. Other technical components. If we view the RPKI supply chain from the top of the screen to the bottom of the screen, it is from the 5 RERs that we derive all trust. They are called the trust anchors. And these trust anchors, they operate the certificate authorities that further down, that are used to certify further delegations in how we made our IP hierarchy. So these RERs publish ROAS through some technology, and then you have all kinds of providers that pull this information into their administrative domain. So you have NTT, TELIA, GTT, they contact the RER RPKI infrastructure to fetch the RPKI data files. But at this point, those files are binary gibberish. They're not human readable. You need special software to do anything with it. And this is where the RPKI cache validators come in. Stuff like OpenBSD RPKI client, Routinator, Fort. There are many excellent open source implementations of the RPKI cache. And these pieces of software take that binary encrypted data, signed data, sorry, and they validate whether the certification chain is correct. Now, at the end of this process, it takes maybe 1 or 2 minutes to go through the whole database and create something that is usable. The decoded information, the validated information that contains those RPKI ROAS, that official document, has to be shipped to the routers for application in real time in the routing policies. So from the RPKI client, Routinator fork style constructs, we jump with RTR to our eBGP routers, to Cisco, Nokia, Juniper, OpenBGPD. And from there, we can do really cool stuff. How do you even get to this point? If you are to kick off an RPKI project or a Good for the Internet project, where you would start, my recommendation is very simple. You get some servers and you install a RPKI cache. That's the absolute starting point to this whole process. Once you have these servers, you need to integrate them with your organization. Add monitoring, set up RTR sessions to the routers, figure out how this fits in your organization, take a hard look at your routing policies to see the exact optimal point to insert the RPKI-related routing policies, figure out where you can and where you cannot enable RPKI in your network, especially the larger networks that have global operations. They often carry multiple generations of devices. There may be technical or other types of constraints on what is in the field. And I think in most networks, there will be some devices somewhere where you simply cannot deploy RPKI. That's fine. You make a note, this is where we can do RPKI, this is where we cannot do RPKI. Write documentation. Make the documentation in such shape that you can take a 3 to 12-month vacation. This will help your colleagues. And that hooks into training your staff. Because nowadays, even if you do not deploy RPKI, you have to add RPKI-related debugging steps or troubleshooting steps to your process, because even though you may not have deployed origin validation in your network, it could be that other peers or other providers have deployed RPKI, and that may or may not impact communication from your network to a network for which RPKI ROAS exists. And do not forget to inform your sales team, your marketing team, because everybody's excited about this. Customers are asking, what's the status on RPKI? And make sure everybody has good answers. What it looks like when you deploy RPKI in one big swoop. What NTT did was we went through extensive preparation. We modeled what would happen if we deployed RPKI. We had a lot of confidence in those emulations. And this led us to a position where we could do a one-day flag day, so to speak. So in the upper left, you see the amount of RPKI invalids that at the time existed in the default free zone, which are most likely the result of misconfigured ROAS. Many operators sometimes struggle to create ROAS when they start announcing more specifics for traffic engineering purposes, for instance. So this steady state of 5,000 invalids that exists in the default free zone is a good metric to understand how far are you in deploying RPKI in your own network. And as you deploy RPKI on more and more devices, the amount of IPv4 or IPv6 invalids should go down. In the lower left of the screen, you see the connected RTR clients. Through a multi-hour process, we, in increasingly larger batches, deployed RPKI on more and more devices in the network. And I find it really interesting that it was only in the last few percent of enabling RPKI that we saw the big drop that signals the milestone of what we accomplished on March 26th. So this is one way of deploying RPKI, but there our colleagues in the previous panel covered other approaches, and all these approaches are valid. You just look what fits with my organization. Is it a flag day? Is it a slower process? It's all good. So after we deployed, a few days later, we checked in with the NOC, and much to my, well, not to my surprise, but this was exactly what I hoped for, that it would be largely unnoticed. Some customers dialed into the NOC asking, what is this RPKI thing you're even talking about? And those are great questions to be answering when you have deployed RPKI and are looking for the real issues. So we started, I will now cover the specifics of the NTT deployment. This is a template that you can follow, but there's many other softwares and many other approaches to structure origin validation in your network. But this is what we did. We started with setting up some servers. These servers use OpenBSD's RPKI client, and through the GoRTR software, we distribute the VRPs, the validated ROA payloads, from the validators to the RTR servers. In our deployment, validators and RTR servers are separate tiers. We did extensive lab testing on all kinds of gear that we have in the wild, but in our lab. And some interesting things were found. Vendors were approached, they were fixed, and cool. Another thing that we did is you may remember from a little bit more than a year ago that we worked to integrate RPKI origin validation in the PM-ACCT software. Shout out to Paolo. PM-ACCT is a traffic analyzer that can correlate flow data, BGP data, and now also RPKI data. And this means that you can carefully inspect what exactly will happen should you deploy RPKI and what the impact on your traffic is. And we also use this tool to approach a small subset of customers where we sense that if we were to deploy RPKI, their ROAS were not optimally configured. And this helped us a lot to get to the point where everybody in the organization felt comfortable enough to give the green light. As mentioned before in the panel, we did find some bugs, and fortunately enough, most of those are cosmetic in nature. So RPKI, it's a new technology. It's receiving more and more exposure. This is cool. This helps us understand the robustness or the weak points of the system. And as we go, we look at those and try to improve. And at the end of it, we had a single flag day. But again, this is not something that everybody must follow. Follow a process that is fitting for your organization. RPKI is an emergent industry trend. This means that over time, looking at route views, risks, or NLNOG's looking glass, we can see that more and more networks are no longer propagating RPKIs or are propagating substantially less invalids than they were before. And I tried to pinpoint what was observed in the raw BGP data to my personal notes and Twitter feed on who did what where. And we ended up with this awesome image that shows that this is an industry-wide project. I don't think we've seen anything of this scale in recent years, so kudos. At present, roughly 2,500 autonomous system numbers from NTT's perspective, so this is our view on the default free zone, appear to be protected or to benefit in some way from RPKI origin validation. And this number, it's not real science. I mean, there's lots of caveats. There could be default routes, there could be intermediate networks, and then stop networks that are not doing RPKI, but because the intermediate network is doing RPKI, it shows up in this test. But to me, given that there are roughly 70,000 ASMs in the default free zone, and we are now already seeing effects for thousands of ASMs, and it will depend on your view on the default free zone, how many exactly, this is really good uptake of this technology. 20% of IP space appears to be covered by ROAS, and we found that this number is proportionally in how traffic flows through our network. So it's not one-to-one, but a substantial amount of the traffic in NTT's network flows to RPKI valid destinations, and those destinations now receive the benefits from us rejecting invalids. In the RPKI, there are a few what I call fill positions that we have to take into consideration. And these fill positions are the key to how the industry was able to implement and deploy RPKI in an incremental fashion. As I mentioned before, on not every router in NTT's network, RPKI is enabled. And this is not an issue because the pieces where we could enable RPKI are so large compared to the part where we cannot yet do that, that we are receiving for more than 95% of our eBGP sessions the protection of origin validation. So this incremental deployment, how does that work? RPKI is an opportunistic security layer. It is optional. It is opt-in. If you don't want to create ROAS, don't. If you don't want to deploy origin validation, you don't need to. Nobody can force you. So in this process, the foundational cornerstone for doing origin validation and letting data flow in a same way through the RPKI supply chain, it is very important that the starting point of the process is trustworthy. And this means that if there is an issue in the cryptography, it should never affect the BGP routing. An issue in the cryptography should result in that no VRPs come into existence, which means that the routes that could have been covered by those broken ROAs or expired ROAs will flip to not found. The expectation of this industry is that any issue in the RPKI infrastructure itself will be reflected as not found in the BGP world. So invalid cryptographic data does not make it to the BGP routers, and therefore all those routes that could have been covered if the ROA was valid are not found. And this is a fail-safe mechanism. And it's kind of weird to think about it. So if it's invalid here, it becomes not found there. If it's valid here, it could potentially become valid there. And if it's valid here, the BGP routes may become invalid. And this is this takes some training. It's a fun exercise, and I hope that this slide helps a little bit in that regard. What about timing? How quick does this RPKI stuff propagate through the internet? What can we expect? And I think a lot of us are accustomed to how the IRR runs on, say, a 24-hour cycle. A LOA-based system runs on whenever the human opens up the photoshopped PDF. But with RPKI, the expectation that we're trying to shape is that if you create ROAs, that you will see the effects in the global internet in an hour or less. And this means that you need to run your validators more than once an hour. Don't make RPKI a 24-hour cycle process. It needs to run faster. It needs to run, say, every 30 minutes. Other cool things we can do with RPKI, things that are either already done or are now in motion and to be released later in 2020. In the RIPE region, there used to be one IRR database. And the RIPE database was a bit complex because that one database contained both authoritative information and non-authoritative IRR information. A project was kicked off in the RIPE community to split this out into an authoritative source and a non-authoritative source. But the non-authoritative source, we don't know what the intentions were of the people that at the time, and it could perhaps be 10, 15 years ago, we're trying to accomplish, and whether that information is still relevant. Cleaning up such IRR databases is really hard if you cannot contact every owner in a streamlined fashion. But what we do know is that RPKI is a higher source of truth than the IRR. With the RPKI, through the chain of trust that is supported by the X509 technology and RPKI on top of that, we have strong assurances that we are looking at the actual routing intentions of the resource holder. So if we encounter in a non-authoritative IRR database a object that is in conflict with a published RPKI ROA, you can delete that IRR object because that IRR object is describing a situation that cannot exist in BGP if you apply origin validation on your edges. So that's one cleanup project that's in motion. And now as people create ROAs for space, we slowly see the amount of information in this non-authoritative database drop down. A second effort related to this is NTTs open source IRRD. This is an internet routing registry daemon that you can use either to cache the various IRR sources or to be an authoritative IRR source yourself. Authoritative is, well, within the context of IRR. And what we're doing in this, in the next release, we are making the IRD aware of what exists in the RPKI, and then we can use that information to scrub everything that goes through the IRD and only output information that is not in conflict with published RPKI ROAS. And I think this is the transitional path for our industry. More and more people create ROAS. More and more IR information that is in conflict with those ROAS will disappear from the IR ecosystem. And I think this is a nice, gentle way to move us forward, and it puts the incentives exactly where they should be with the resource holders that that create the ROAS. So you can click this links for more information if you download the slide deck later. A study resource that has been mentioned a few times, but it cannot receive enough praise. Good work, Alex Bent and your team. rpki.readthedocs.io. I consider this a community-driven documentation project that is the go-to resource for anybody that needs to learn about the RPKI. If you need to start somewhere, this is it. This is easy-to-read documentation that has lots of cool info on what works, what doesn't work, what are becoming the BCPs, etc. If you're more hardcore, there's the IETF RFC specifications that contain all the nitty and gritty of how the RPKI works. Some of these documents are quite lengthy and can be hard to understand if you're not writing an implementation at the same time, but some of them are actually really readable documents that are only a few pages and describe what exactly it is that your router will be doing. One of those is RFC 6811, and that is the BGP origin validation RFC. If you ignore the boilerplate and the stuff at the end, it's 2 or 3 pages. I recommend everybody to read that document. Does RPKI solve all internet routing problems? No. And there will never be a silver bullet. That's simply not how the internet works. But there are many initiatives underway to improve the RPKI and improve the functionality of the RPKI. These collaborations happen in open standards bodies like the IETF based on open source software. And this is where we work to keep honing RPKI to be not an ugly pig that we made fly, but something we love and enjoy using. My request to you as network operators, please create RPKI ROAS for your internet number resources. If you create a ROA, NTT will use it. And this is good news because it gives you immediate, firm control. It puts agency in your hands about how routing happens in NTT for your number resources. Then secondly, work to deploy RPKI-based origin validation on all eBGP sessions in such a way that you reject invalid announcements. And this means apply RPKI on your transit connections, on your peering connections, on your customer-facing connections, on route server-facing connections, on the route servers themselves. The cool thing with RPKI compared to the IR, the RPKI has 5 trust anchors, whereas the IR had all kinds of databases, and nobody knew what is the complete set of databases that we need to take into consideration. This left the thing open-ended, which in effect meant that you could not apply IR-based filtering on your transit-facing sessions. But with RPKI, that issue does not exist. We know that the 5 trust anchors provide us with a complete set of the space under the RER's governance, and therefore it is possible to apply RPKI on every eBGP session. If you're looking for more information, network information centers such as the internet registries like ARIN are a great place to go and find more study material and find the tools to create ROAS. Manners has a bunch of information on this. There's the RPKI mailing list hosted by NLNet Labs, where operators zoom in on specifically RPKI in the context of compatibility issues or interoperability issues or whatnot. If you ever have any question about RPKI, this is a great mailing list with people that are dedicated to help you. And finally, there's also an IRC channel. Good old IRC, the thing on which we are building this internet. the #IX IRC channel is a good place to do real-time communication with fellow internet operators if you have questions about RPKI or BGP routing in general. So here you have a bunch of different places where you can go to find more. And that's it. This brings me to the end of my presentation, and it seems that I ran over by 2 or 3 minutes.
Okay. Thanks, Job. Doesn't look like we have any questions in the queue, so let's conclude here. And a reminder, the BOF, the Birds of Feather sessions, there is a link that we have dropped in the chat room, so feel free to join that with Zoom. And hope to see you at the BOFs. And thank you very much, Job.
Take care, everyone.